Assalamu alaikum students. In this video we are working on applications of algebraic identities and we are going to use them to solve complicated math problems. But before we start using algebraic identities, let's see, do you know the algebraic identities or not? Let me ask you a first question. I have given you two binomials and you are just supposed to multiply them. So just please pause the video right here and solve this multiplication on a piece of paper. I am continuing the video, but if you haven't solved it, so just keep the video paused. And if you are having any problem, I am giving you my video on multiplication of polynomials that you can watch before watching the remaining video ahead. Okay, so whenever we multiply two binomials, we have to multiply each and every term of the binomials with each other. So starting with x times x, which equals x squared. Next we are multiplying x with y, which is negative y, so we are having negative xy. Next we have y in the first binomial, so multiplying y with x, which is positive xy, and then multiplying positive y with negative y, we have negative y squared. This is simple multiplication of monomials. Now we need to combine the like terms. These two terms are like and one is positive and the other is negative, so they will be cancelled out like this and we will left with x squared minus y squared. This is the first algebraic identity, which is known as difference of squares, because you can see you had squared, which is x squared, then you subtracted or find the difference with the another square, which was y squared, and it equals the sum of the bases and product of the sum of the bases and the difference of the bases, right? So this is the first identity. Now for the next identity, I am just having the same binomials. Now I am changing the sign of the second binomial and making it a positive sign, and you are again supposed to multiply these two binomials. Okay, we have already seen in our first question that whenever we multiply two binomials, we have to do the multiplication with each and every term of them. So starting with x times x, which equals x squared, then x times y, which equals xy, then y times x, which also equal xy, then y times y, which equals y squared. Now we are combining the like terms like xy and xy, and they both have positive signs, so we will have xy or the coefficient of 2. And copying down the remaining term, so this is our second identity, and you can see that in the right hand side we have the same base which is being multiplied a total of 2 times. X plus y is multiplying with x plus y, which we can also write as x plus y whole squared. So this is the second identity, which is x plus y whole squared equals x squared plus 2xy plus y squared. Now moving to the last identity, we need to recall you in the start of the video. And again we are taking these two starting binomials, and this time I am changing the sign of the first binomial and making it a negative sign. And you are supposed to find the product of these binomials. Starting with the first terms, x times x equal x squared, then x times negative y, which equals negative xy, then negative y times x, which equals negative xy, then negative y times negative y, negative times negative equal positive, so we have positive y squared. Now again we have the like terms in between, so we need to combine them. Negative times negative, so we have to do addition. So negative xy equals negative 2xy. So this is the last identity which we have solved, and in this identity you can also see that there was the same binomial which was multiplied by itself a total of 2 times. So again we can write it like x minus y whole squared, right? So this is the third identity, x minus y whole squared equals x squared minus 2xy plus y squared. Now we have recalled all of these three identities which are known as algebraic identities, and we are going to use these three identities to solve some complicated math problems. So let's start doing this. Starting with the first question, which is when you're supposed to give in the find the value of x squared plus y squared, and you are given x plus y and xy. Okay, so the data is here. Now you need to combine or search in the identities that which of the identity offers you all of these terms in it. Where in which identity do you have x squared, y squared, x plus y and xy? In which identity do you have? Don't be confused that you must be thinking that in the first identity I have all of these three terms, but don't confuse that positive. Here we have negative, so we cannot have this, so reject it. Next, if we combine the first, we have x plus y, so we have x plus y. Then we have x and y squared. We can switch their positions, so we can have x squared plus y squared. So here we have this, and last term we have xy, which is also given. That means this is the identity which we can use to solve this problem. Okay, but as we have already discussed, to apply or put in the values, we have to switch their terms like this. We have written plus y squared before plus 2xy, which we can do according to the commutative property of addition. We can change their orders. Okay, now we can see we have x squared plus y squared together, which we are supposed to find out in this question. So now let's start putting in values, starting with x plus y, which is given to 4. So putting 4 in its value. Next, we can put in the value of x minus y, because it was also given in the question, equals to 3. So putting to its place, 2 times 3. Now we need to do some simplification, like starting with 4 squared, which equals 4 times 4, simply equals 16, and we are multiplying in this term, so 2 times 3 equals 6. Next, since we need to find x squared plus y squared, so we have to separate it on the one side of the equation, and this 6 is disturbing us. So we have to remove this positive 6 to the other side of the equation. Since it is being added on this side, so when it will be converted, it will be subtracting, right? So now we have simple subtraction. 16 minus 6 equals 10, and which is equal x squared plus y squared, which was required in our question. You can see x squared plus y squared, which we have found. So you see, whenever according to the identities, we can easily find out our questions like this. So as you can see, when you have x squared plus y squared and x plus y and xy, so you always apply x plus y whole squares identity. Similarly, when you have x minus y, xy, x squared and plus xy squared, you have to apply this identity, right? Because when you switch its order, so you will have x squared and y squared, and this term will be in the last of this equation. And here you have x minus y, so you can easily solve that part as well. So now let's moving to the next question, which is quite complicated. That might be quite complicated by using the simple identities. Okay, here we have another question in which you are supposed to find x squared plus y squared, where you are given x plus y and x minus y. Now if you look at all of these three identities, you would not find all of these three given equations, or expressions, like x square plus y square. So x square plus y square is normally found in these two terms, right? But in this term you have x plus y, and in this term you have x minus y, that is given, and the second term is xy, which is not given in your question. So that means neither you can apply this identity nor you can apply this identity, right? So what you can do, and in this identity you have subtraction, difference of a square, and you need to find the sum of squares, so you cannot even apply this identity. In this case, whenever you are given the sum and difference and you are supposed to find the sum of squares, you have to combine these two identities. and you have to add them up. You know what are the values of these two identities, so you are just putting their values. X plus y whole squared equals x squared plus 2xy plus y squared, where x minus y whole squared equals x squared minus 2xy plus y squared. Now you can cancel out the like terms, like these two are like terms, they can be cancelled out because they have opposite sign and same coefficients with each other. Copying down the remaining terms, now in this last step you can see you are having x squared plus y squared a total of 2 times, so you can write it as 2 times x squared plus y squared. Because you are having the same addition, so you have written as multiplication. In short, you have solved that x plus y whole squared plus x minus y whole squared equals 2 into x squared plus y squared. Now if you look at this identity, you are having all of your terms or expressions which are given in your question. So you can easily put in values. So starting with x plus y, which is given to 8, and putting its value like this, 8 squared. Next you have x minus y, which is given to -6, so again putting its value to its place. Remaining x squared plus y squared, which is required, so we have to just copy down to the next step. Next we have to, you have already solved in the last question. After putting in value, we just need to simplify. So we starting with 8 squared, which is equal 64. Then we have -6 squared, which equals positive 36, because negative times negatives equal positive. Now we need to find x squared plus y. Okay, before doing any switching on the either side of equation, we have to first make sure that all of the sides are completely simplified, and here we still have addition. So first we do addition. 64 plus 36 equal 100. Now we cannot solve any of one of these sides, so we are not, now we have to just separate out the unknown which we are supposed to find, which is x squared plus y squared, and we are having 2 along, so we have to remove this 2 from here to the other side of the equation, and 2 is being multiplied with x squared plus y squared, so it will be divided on the other side. Okay, now we have division. 100 divided by 2, which simply equals 50. So we have found 50, which equals x square plus y square. So you can see, if you are given x plus y and x minus y, and you are supposed to find x squared plus y squared, so you have to make the combination of these two identities, right? X plus y squared plus x minus y squared, right? So you can have any other unknown out of these three expression, like for example you could be given x squared plus y squared, and x plus y could be unknown. But whenever you have combination like x squared plus y squared, x plus y, and x minus y, whenever you have these three, you have to use this combination of these two identities, and your question will be simplified. Now in the last of the video, it is very necessary to solve another question which will help you out. Let's see what that question should be. Okay, like this. Find the value of x minus y when x plus y equals -9 and xy equals 20. Again, if you look at the identities, none of the identity will help you out directly. Now you again have to make some combinations. So just keep remember, when you have x plus y, x minus y, and the product of them, so you have to again combine these two terms, but for this time you have to subtract them, right? You need to identify in the last question what you have and what you did. You did addition when because you have a different expressions which were given in the question, but this time you have addition, difference, and product, so you apply this division between these two identities. Now we have the values according to the identities, so we have just put in their values. We have mentioned the brackets here because we are subtracting, and before doing subtraction we have to change the sign of this second polynomial. So changing its sign, x squared which were positive has become negative, it has negative because it was positive, and similarly it was positive, so it has become a negative. Right, now we can combine the like terms. So starting with x squared, since we have x squared positive and negative, so they are cancelled out. Similarly we have y squared and negative y squared, so okay, they will also cancel out, and we will left with 2xy plus 2xy, that will combine to get 4xy. Right, so we have solved that x plus y whole squared minus x minus y whole squared equals 4xy. And if you look at this identity, you are having all of the related term of this question, like you have x plus y, you have x minus y, and you have xy. So these were the three terms that were required. Two of them could be given and one should be unknown, so you can easily simplify this identity. Now start putting in values, like starting with x plus y, which equals negative 9, so putting its value. Next we have xy, which is given to 20, so 4 times 20, and we are supposed to find x minus y, so we have just copied it down. Next we need to do simplification, starting with negative 9 squared, which equals 81, and since second is 4 times 20, which equals 80. Now we have to separate out x minus y, since we need to find its value, so we have to separate it out on the one side of the equation. Look at these two highlighted terms, so if we switch their places, you can see x plus y whole squared will be separated on the other side of the equation. 80 was positive on this side, when it went to the other side, so it has a negative sign along, and it had a negative sign when it was switched to the other side, it has positive sign. Okay, now we have a subtraction right here, so 81 minus 80 equals 1. Now we have solved 1 equals x minus y whole squared, but we need to find x minus 1, so we have to remove this square from here. And you better know, to remove a square from either side of equation, we have to take square root on the both sides. On this side, square root will cancel out from square, and on this side, square root of 1 is simply 1. So we have 1 equals x minus y, which was supposed to find in the question. So you can see that in this question, what we did, we just make the subtraction of these two identities, and we had the relevant identity which we could have solved or used to simplify this question. So in the last of the video, I would like to show all of the 4 or 5 identities we discussed in this video. If you look at 3 or starting identities, these are basic identities which you can find out simply by multiplying the binomials, and you should remember them. And the remaining 2 we made according to the solution we required. So just keep them, remember, whenever you have x plus y, x minus y, and x square plus y square, these three expressions given in your questions, so you always have to combine these two terms, these two identities as addition. And whenever you have x plus y, x minus y, and xy, so you have to subtract these two identities. So I hope the video will be helpful. Now you can solve all of your questions of exercise 4.7. So please open your book and solve all the remaining questions I did not discuss in the video. One more thing I would like to highlight, I am giving you my another video you can have on your screen, and if you don't know how to solve the question number 5 of this exercise, which we have already discussed in rationalizing denominators video, so we would refer, if you would like to watch that video again, so you can watch it again. Thank you so much.